Hello everyone, in this video we are just going to write down our first ever program of LED blink and we are going to interface LEDs with our Renesas RL78 bar F14 series microcontrollers. Let's get started. So the microcontroller that we are going to use in this video or throughout this course is R5F10PPJ, which is available in the development board of QBR5F10PPJ TB. So this is a development board out of Renesas RL78 F14 based microcontroller series, which is having R5F10PPJ mounted on it. So you can buy this development board or you can use any of the Renesas development board, or you can use any other Renesas based development board of RL70 series from any other vendor. But only thing is you just want to configure your project in CubeSuite plus IDE as per the microcontroller name provided for the startup files required for the microcontroller. So first thing that we are going to learn is I'm just going to open the user manual of the development board that I'm going to use. So you can see this is the user manual of the development board that I'm going to use. You can see this is the microcontroller series which is available in this development board, that is the target board, and the development board name is QBR510PPJ-TB. So this is the microcontroller name that is available, R510PPJ of the series RL78F14. So in this development board, as we discussed before in a separate video, we are having two different LEDs on board available in this microcontroller. You can clearly see LED 2 is connected to P67 of the port pin and LED 1 is connected to P66 of the microcontroller port pin. So we are just going to configure, let's take it to be P67. So what we are going to do is we are just going to configure this P67 port pin as output pin, and we are going to perform the blinking operation in this particular LED which is connected to P67, which is available on board in this development board. So coming over to the pictorial representation of the development board, you can clearly see here is the LED 2. So this rectangle right over here is the LED 2 which is available on board. So we are just going to perform blinking operation for this LED by writing down program in our CubeSuite plus IDE in this video. And let's see how the LED is connected in hardware using the schematic provided from the vendor. So when I move a little down, you can clearly see here is the P16 and P17. So these two are the pins to which the onboard LED is connected in our target board or development board QBR510PPJ-TB. So you can clearly see these two port pins are connected to the cathode of the LED, and the other end of the LED, that is the anode of the LED, is connected to 1.6 kilo ohms resistor and then to power supply pin VDD of the circuit. So this K represents cathode right over here. These two K represents cathode and these two A represents anode. So anodes of the LED is already connected VDD of the development board, that is the power supply line of the development board or 5 volt signal of the development board through 1.6 kilo ohms resistor. So for turning on this LED, I just simply want to turn off this particular P66 or P67. So this is what we want to do for turning on this LED. And for turning off this LED, I just want to make this P66 or P67 corresponding pin to be high. So this needs to be done for turning on the LED and as well as for turning off the LED. So for turning on the LED, I just want to make the P67 to be low, and for turning off the LED, I just want to make the P67 to be high. That's it. So this is the circuit configuration of LED. So I just want to turn off the pin for turning on the LED, and I want to turn on the pin for turning off the LED. So let me just open the CubeSuite Plus IDE for writing down our program or for start writing our program. So after installing the software, you can just directly open the software. So this is the first time that we are going to write down our program. That's why I'm just going to explain you all the code generation strategies and all the options that you want to do for configuring for a particular microcontroller in this CubeSuite Plus IDE for CCRL clearly. So after opening the IDE, what you want to do is you just want to click over this project and then click on create new project. And in this first tab that is popping out, just type in the microcontroller name that you want to use in your project. So in my case, it is R5F10PPJ. And then select the microcontroller as per your requirement. So mine is a 100 pin microcontroller. You can clearly see in the bracket it is mentioning like 100 pin. So just select on this and then provide a name for your project in this project name tab, and then click on this browse button right over here for selecting the location where you want to store the project files. So I'm just going to select somewhere right over here. And then click on create for creating your project. So if you are using any other development board which is having different microcontroller but of the same series RL78, you can just search for that particular microcontroller right over here in this step before clicking on the create button in the tab. So once the project is created, you can see on the left of the IDE we are having a particular tab called project tree. So this particular tab will be containing several segments of the microcontroller. Those are very important. First and foremost segment is the pin configurator segment, and next segment is the code generator segment, and the next segment is the file segment. So these three are the major segments that is generated for your microcontroller. So this pin configurator segment is useful for visualizing the configurations that has been done for your particular microcontroller. So when I double click on this device top view, you can clearly see this is the layout diagram of my microcontroller RL78 bar F14, that is R5F10PPJ. You can see each pin description has been provided right over here. Once the configurations is done, you can see the configurations that has been done as a whole in this layout. So for that purpose, this pin configurator has been provided. So using this code generator segment right over here, you will be able to generate your own base peripheral software that is required for your microcontroller as per your user application. So I will be showing you how to configure your microcontroller in a while as per your application needs. But before that, we just want to do some basic configurations that needs to be done for almost all the programs. Just double click on this clock generator tab inside the code generator, and you can see these configurations, that is the default configurations that needs to be fixed in the microcontroller before moving on. So let's take an example. This particular PIOR00 is yet to be assigned to the function TI00, and the respective port pin for that function is P17 by default. So if you need any alternate port pin to be configured for this function, let's check it out. Just click on this drop down. You can see the alternate pin that can be assigned with the same function is P66. So if you want that particular pin to have this feature, you just want to select that. So most often we will not be changing anything right over here. We can use all these functions for all these pins as it is. So if in case anything is required, I will just intimate you in future lecture videos. but for now we will be fixing these settings by default. Just click on fix settings for fixing these settings as default settings in this microcontroller. Once that is done, just click on chip debug settings tab right over here, and this is a tab which is useful for enabling the debug option in your microcontroller. So if this is disabled, you will not be able to program your microcontroller using debugger, or you will not be able to debug your microcontroller using debuggers like E1, E2, E2 Lite, etc. So for that, just click on used radio button right over here. In my case, I'm just going to select the E1 right over here. If you are using any other emulators like E2 or E2 Lite, you just want to select the respective radio buttons right over here. So in my case, I'm just leaving this to be E1 selected. That's all about the basic configurations that you want to do. In addition to that, just double click on this watchdog timer right over here in the project tree inside the code generator, and you can see by default this watchdog timer is enabled, or it is used by the code generator. So you just want to disable it. So I will teach you what is this watchdog and how to configure this watchdog in this microcontroller in a separate video. And for now, for almost all the videos, I will be disabling this watchdog, and in a separate video we will learn how to enable the watchdog and how to utilize its features for safeguarding our microcontroller. That's it. These are all the required basic configurations that you want to do for almost all the programs. So now let's just move for configuring our microcontroller as per our application needs. Now for configuring this corresponding P67 pin as output pin in our microcontroller, what you can do is you can just double click on this port right over here, which is helpful for configuring a particular port pin as digital input or digital output pins. So in this port segment of the code generator, you can see all the ports that is available in this microcontroller: port 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, etc. So in our case, we are just going to configure the port 6, and particularly the port pin P67. So you can see this is the pin that we want to configure, P67. So just click on this radio button out for configuring this P67 as output pin in our microcontroller. That's it. The configurations that you want to do for connecting an LED to P67 port pin of the microcontroller is done along with the clock generator settings that we have already done before. So for generating the base software or register software required for this particular configurations that you did right over here, you just want to click on this generate code button right over here. Just click on this generate code. You can see the code is being generated. That is the base software for the peripheral drivers is being generated. So the code has been generated. Just click on this plus icon. I'm just going to minimize this. Just click on the plus icon near the code generator folder inside the file folder right over here. So you can see these are the generated .c and .h files, that is the source files and header files as per the configurations that you did in this code generator design tool. So just open this main.c file. So this is the file that we will be altering most often, or we will be creating our own user defined .c and .h files as much as required inside this code generator folder right over here as per our need. So most often this is the only file that we will be altering, which has been provided or generated from this design tool code generator. So in this main.c file, you can clearly see there are two different functions provided for us. One is the void main function and another one is the main user init function. So this main user init function is called right over here in this void main function just before this while of 1. So this while of 1 is nothing but an infinite loop in which we will be writing down all our user programming lines which needs to be executed again and again throughout the lifetime of the program. And in this particular user init function, main user init function, we will be writing some of the programming lines which needs to be executed only once in the lifetime of the program, and we don't need these particular lines to be executed again and again throughout the lifetime of the program after being executed once. So those kinds of lines will be written inside this user init function, and the user programming lines which needs to be executed again and again throughout the lifetime of the program will be written inside this infinite loop or the super loop while one. So this is the two parts of an embedded program. Just understand the initialization part and the infinite part. So in the initialization part, we will be writing down the programming lines which needs to be executed only once in the initial segment of the starting part of the program, and the infinite part of the program is the programming lines which needs to be executed again and again until the lifetime of the microcontroller. So this is the logical part which will be keep on executing until the microcontroller is stopped. So as per our understanding, we have configured P67 as output, and as per our hardware, we just found out that making the P67 low will turn on LED 2 of the development board, and making the P67 high will just turn off the LED 2 of the development board that I am going to use. So we just now found out these things, right? LEDs in my development board that is available on board in my development board is connected to P67, and one more LED is also connected to P66, but the LED that I am going to use is P67 orange LED. And when I make the P67 low, as per the hardware configurations that has been provided in my development board, when I make the P67 low, this will turn on the onboard LED 2, and when I make the P67 high, it will turn off the onboard LED 2. That's it. So these are the things that we are going to do. So for now, just we will be testing whether the LED is turning on or not. So in previous some of our videos, we just learned the basic bitwise operators that is available in C language, as well as some of the techniques for setting a particular bit in a register of a microcontroller, also for clearing a particular bit that is available in the register of a microcontroller without disturbing other bits in the register of the microcontroller. So I hope you remember those techniques. So for setting a bit in a register without disturbing the bits, the technique goes like this, that is register name is equal to register R of 1 left shifted by bit number, and for clearing bit in register, we just want to write like 1 left shifted by bit number. So this is the methodology that we will be applying for setting a particular bit in a register without disturbing other bits, and this is the methodology that we will be using, or technique that we will be using for clearing a particular bit in a register without disturbing the other bits. So in our case, for turning on the LED, we just want to clear that particular bit in the corresponding register. So I'm just going to apply this technique right over here for clearing a particular bit for turning on the P67 LED. So in our case, the register is P6, which is the port data register. So I can write like P6 is equal to register name again ampersand of negation of 1 left shifted by, I just want to clear the 7th bit for pin number 7. So in the port 6, I am just clearing the bit number 7. Let me just save this and let me just build the program. So for building the program, just click on F7 in your keyboard, or you can use this icon right over here which builds the project. You can see the build ended with 0 errors and 0 warnings. And for rebuilding the project, you can also click on Shift plus F7 or the icon right over here. Again the rebuild will happen. That's it. And now connect your development board to the emulator that you are using, and then connect the emulator to the PC through USB cable, that is the mini USB cable. And before that, you just want to select the tool for loading the program to the microcontroller. So for that, just right click on this RL78 simulator or debug tool icon right over here, and then hover over using debug tool and select the respective debugger that you want to use. In my case, I am just going to use RL78 E1 serial. So this emulator will not be available in the market for now. For now, you can use the alternate version of this to be E2 Lite, which will be affordable for you in case if you are looking to be practicing this for the beginning stage. Or if you are doing this as a professional, you can buy E2 emulator also, which will be a bit costlier. So the alternate version for this E1 serial is E2 Lite, which will be of same cost. So I am just selecting E1 serial, which I am going to use. So let's go to the hardware and see the hardware connections that I have made. So now let us see my hardware configurations that I have done. So this is the development board that I am going to use, that is the QBR510PPJ-TB, and I have connected the emulator line of the development board to my E1 emulator. You can clearly see this is my Renesas E1 emulator, and I have connected this emulator through mini USB cable to my laptop right over here. And the programming pin of this emulator, I have connected this FRC14 cable to the FRC14 connector right over here in this development board, that is my target board. You can see this red wire which is connected or soldered to this VDD pad of the development board. So this VDD pad is nothing but the power supply line pad which I have connected to the 5 volt SMBS right over here, that is the positive line of 5 volt SMBS. So this SMBS, you can clearly see this SMBS is a 5 volt SMBS. And another black wire from this negative supply of the SMBS I have soldered to the ground pad of this development board. You can clearly see here is my ground pad. So this black wire is soldered to the ground pad of this development board, and I have connected to the ground of this SMBS, that is the digital ground, and I have powered this SMBS through 230 volt supply from my house. That's it. That's all about the configurations or hardware configurations that I have done for blinking the LED. Let's see the output in the hardware. Let's program this hardware for blinking the onboard LED that is available in my development board. And now I'm just going to dump the program to my microcontroller. For dumping the program, just click on this icon right over here. So this will download the program to the debug tool after build. So you can also click on F6 on the keyboard for doing this. You can see the program is being downloaded using the emulator RL78E1. So automatically this CubeSuite Plus for CC IDE switches to the debug view itself. You can see the debug view has been mode. Now for running the microcontroller, you just want to click on this play button or F5 in your keyboard. So when I run, you can clearly see the LED is turned on. That is the LED 2 in my development board, which is connected to P67 of the microcontroller port pin, has been lighted up. So our program is working fine. So for stopping the microcontroller operation or running, just click on the stop button or shift plus F5 in your keyboard. So I have successfully stopped the microcontroller operation. Now I am just going to write down the logic for blinking this LED. So this is the steps that I want to perform for blinking the LED. I just want to turn on the LED and I want to wait here for a particular time, and then I want to turn off the LED, and here I just want to wait here after the turning of the LED. And since we are just going to write all these 4 lines inside the while of 1, after this delay, this first line will be executed and the operation begins from this line again, and all these lines will be executed because we have written all these lines inside the while of 1. And for turning off the LED, we are just going to set the particular bit in the register. So as per our hardware configuration, we just want to set the bit for turning off the LED. So I can write like P6 is equal to P6 R of 1 left shifted by the same bit number 7. So this will turn off the LED2, and for making the manual delay, I am just going to write down my own delay function in the top of the file. So right over here or right over here between these two comments, I am just going to write down my delay function. So it goes like void delay of long d. So inside the delay function, I am just going to write like while of d minus minus. That's it. So this is a very simple loop delay. So the program will be decrementing this particular parameter variable which has been passed to this function, and whenever this variable becomes 0, this loop will be exited. So as per the value that you are providing as a parameter to this variable, this delay will wait here until the variable becomes 0. So that's all about this delay function. So in this place, I am just going to call this delay function, and I am going to pass like 1 million as the value right over here. Now I am just saving this project or source file, and then I am just going to dump the program to the microcontroller. So for dumping the program, you need not come back to the normal mode from debug mode of the IDE. You can directly dump the program to the microcontroller. Just click on F6 in your keyboard or the icon right over here. You can see the program is being loaded, and when I click on this play button, you can see in my hardware the LED2, which is connected to P67 port pin of the microcontroller, is blinking. So I hope you learned how to configure a particular digital pin of the Renesas microcontroller series RL78 to be digital output pin using code generator design tool available in the CS Plus for CC IDE. And finally, you learned how to write your user program for the configurations that you did. That is, for that configured output pin, we learned how to write the user program in this main.c source file generated for our convenience. And finally, we learn to write the LED blink program for the LED which is connected to P67 of the microcontroller, that is available in the development board QB R510PPJ TB. See you in the next video. Thanks for watching.